Hi, good morning. So today I'm going to the office again. I'm a bit late though, but it's okay. I can join in the virtual meetings. Um, Today, as promised, I'm gonna talk a little bit about Cisco. Uh, this is the part where I studied a lot during my stay in the corporate world, actually until now. But um, yeah, let's talk about some basic things. Some of my colleagues actually are a bit confused about switch versus routers. That stuff. Because it's a little bit confusing. I kind of understand because some switches are performing layer 3 nowadays. Most of them actually, because it can, right? It can. So routing is not really a special thing, that only a router can do nowadays. So when it comes to devices, the main difference is what header information on the packet is the device looking at. If it's layer 2, then it's a switch. If it's layer 3, then it's a router. That's simple, right? So what is a layer 2 header? It comprises of MAC address and all of this other stuff. And these MAC addresses are unique. So it's not like there's a device that has similar MAC address to the other, right? So it's a unique address assigned by the manufacturer. And usually the start of this MAC address is unique to the organization that manufactured it. For example, Cisco has the same starting characters for the MAC address. Okay, and then what other things? VLAN. VLAN has been very popular. It's used to logically separate the ports of the switch, meaning only the same devices with the same that belongs to the same VLAN ports same VLANs, right, are able to communicate with each other. So if you want to communicate between different VLANs, you need routing capability of the device, and this is where layer 3 switches comes into play. They're able to route between VLANs. Okay, but if that is the case, then how does a router differ from a switch, right? If the switches nowadays are all layer 3 and can perform basic routing, then what's the difference? Why buy a router, right? Well, number one is scale. Okay, if you're going to perform full routing capability, like an edge router or whatever, core router, and if you're going to run OSPF and all these things, BGP, ISIS, EIGRP, for God's sake, if anybody uses EIGRP, and if you need a full-scale routing, with VRFs, MPLS, then you'll need a router because the switch cannot scale up to that point. There's a limit to the routing capability of a switch. Okay, in terms of routing table entries, right, that eats up memory. In terms of maybe A6, I don't know, but whatever resources, the router is optimized for routing. Okay, the switch, it's optimized mainly by default for layer 2, but I think you can tweak it at some point, to become more like a router. But why do that? If you, for example, if you need an edge router, right? why buy a switch, right? Go and use a router. And another thing, okay, another thing that people get confused, uh, lack of a better word, I think is using BGP, right? A lot of people, when they use BGP, they don't manipulate BGP too much, right? Why? Because they're afraid to touch BGP. But BGP was made for the internet. It's the routing protocol of the internet. And by default, if you don't do anything, it will default to the AS path. And the AS path, it's like when you're navigating, the navigator app may point you to the shortest time route, but it's twice the distance, right? And you might not want that because it's too far, right? So same with the AS path. The shortest AS path may not always be the best path, may not be your preferred path, but you're looking at the most the best latency, or the shortest router hops maybe, or lowest possibility of congestion, right? So those are the things that you consider, right? So you can manipulate BGP if you want, usually for the outgoing traffic you use the AS path prepending, and for the incoming you use the local preference. I think that's it for today. I'll make a separate video maybe at home, not while driving, for Cisco stuff, technical stuff, a more detailed one. So I'll have to drive fast, so see you later, guys.